we discussed complex numbers. The number I, root of minus 1. Root of minus 1 is I, so that I square is minus 1. Then expressions involving I, that is A plus IB. Expressions of the form A plus IB, that's what a complex number. So Z is equal to A plus IB. Here A and B are real numbers. It is a complex number. And these complex numbers are imaginary numbers. They are not real numbers. They are imaginary numbers because it involves I. So I is root of minus 1. And real number, we cannot take square root of a negative number. Again, out of this A and B, if A is 0, then the complex number becomes pure imaginary. If B is 0, it becomes a real number. And generally, if A and B are not zeros, it is an imaginary number. Then also we discussed how to evaluate higher powers of I. To evaluate higher powers of I, we write I square raised to something. I square raised to something. Because the value of I square can be written as minus 1. That also we discussed. Now, next few more definitions. Write it. First one. Two complex numbers. Right. Two complex numbers. Two complex numbers are equal. If two complex numbers are equal, or two complex numbers are equal, if their real and imaginary parts, if their real and imaginary parts are respectively equal. If their real and imaginary parts are respectively equal. Two complex numbers are equal. Yes, if the real and the imaginary parts are respectively equal. One of you wrote, all real numbers are complex numbers, but all complex numbers are not real numbers. That is correct. All real numbers can be considered as complex number with imaginary part 0, whereas all complex numbers are not real. That's correct. Then another one asked, if A and B are 0, what happens? If A and B are 0, it becomes 0. That's a real number. So two complex numbers are equal if their real and imaginary parts are respectively equal. That means that is A plus IB is equal to C plus ID. This means A is equal to C and B is equal. If A and C are equal, B are respectively equal. If real parts are respectively equal and imaginary parts are respectively equal, then those two complex numbers are equal. Next definition. Two complex numbers. Before A, what is that? Is I wrote this is not a symbol. I wrote that is ID. A plus ID is equal to C plus ID. Next one. Two complex numbers. Two complex numbers which differ. In the sign of their imaginary part. Two complex numbers which differ in the sign of their imaginary parts. Sign of their imaginary parts are called conjugates. denoted as Z and Z bar. So two complex numbers which differ in the sign of the imaginary part. That is, if Z is equal to A plus IB, then the conjugate of Z, we denote as Z bar, will be A minus IB. So two complex numbers which differ in the sign of their imaginary part. In the sign of their imaginary part. Two complex numbers which differ in the sign of their imaginary parts. Example, 3 minus 4i and 3 plus 4i are conjugates. Similarly, minus 2 plus 5i and the commonly seen mistake, we will write it as 2 minus 5i, not 2 minus 5i, minus 2 minus 5. Only sign of the imaginary parts are conjugates. Then, next point. If Z is equal to A plus IB, if Z is equal to A plus IB, then modulus of complex number, modulus of complex number, modulus Z is equal to root of A square plus B square. Another definition. So modulus of a complex number. So remember this definition. Modulus of a complex number, conjugate of a complex number. So modulus of a complex number is root of A square plus B square. Next point to remember. The multiplicative inverse. The multiplicative inverse denoted as the multiplicative inverse is denoted as Z raised to minus 1. And Z derivative as Z inverse. Z inverse is equal to Z bar by modulus Z square. Z bar by, that is, if Z is equal to A plus IB, we know Z bar is A minus IB. Modulus of Z is root of A square plus B square. Then Z inverse is Z bar by modulus Z square, which is Z bar means A minus IB by modulus is root of A square plus B square. So square of it will be A square plus B square. So number that is Z bar. Z inverse. Z inverse is These are the points to remember. Then, few more things, the basic things. See, root of A and the root of B is equal to root AB only if A and B are non-negative. The root of A into root of B is equal to, we learned that root A and root B is root AB. But that we can take only if they are non-negative numbers. That means, that is, the root A into root B will not be equal to root of AB if A and B are negative. See, for example, we know that -1, root of -1 and -1. We cannot take it as -1 and -1. See, -1 into -1 is root 1. But root of -1 we know that is I into I. I into I is I square, and I square is root of I square is -1. Whereas here we get 1. So it is not possible. So remember, the root A into root B is not equal to root AB if A and B are negatives. Then few more properties, these are all properties. You should have an understanding of this one. What will be asked examination of this one later. See, modulus of Z1 into if two complex numbers. That is, modulus of product of this will be product of their modulus. Modulus of Z1, so it will be product of their modulus. Similarly, Z1 by Z2 will be modulus Z1 by modulus Z2. Here, denominator is not equal to naturally. Similarly, the product of conjugate of a product. Conjugate of this product will be Z1 similarly Z1 sum of Z2. Z1 by Z2 the whole bar is Z1 bar by Z2 bar. Here also like real numbers only, because see, if you are reading this as sentences in sentence, these are two complex numbers. This is modulus of product of two complex numbers. Modulus of product of two complex numbers, that is product of their moduli. Product of their modulus. Similarly here, quotient of two complex, modulus of quotient. Here, conjugate of the product is product of their conjugates. Conjugate of product is product of conjugates. Like that. Here, just by remember those things. Now, so the important thing for doing questions, the main things to remember what we discussed is writing complex number in standard form, A plus IB form with real part and imaginary part. Real part means part without I, imaginary part is part with I. You know the value of I. I root of -1 is I, or I square is -1. To evaluate higher powers of we learned it yesterday. Write it in terms of I square. Then put the value of I square as -1. Today we will discuss three things. One is conjugate, A plus IB. Conjugate is A minus IB, denoted by bar. Then inverse. Inverse, before that modulus. Modulus is root of A square plus B square. Then inverse. Inverse is conjugate by square of modulus. Remember those three things. Now coming to exercise 5.1. The question is we express it in the form A plus IB. First question. Z is equal to 5I into minus 3 by 5I. It is nothing. Just multiply 5 into minus 3 by 5 I square. Is it I into I is I square? This cancels. We got minus 3. Value of I square is -1. So we got it as 3. We got it as 3. Now we have to write it in A plus IB form. A plus IB form. So real part and imaginary. A plus I. So how can therefore Z is equal to A. Real part is 3 plus 0I. There is no imaginary part. A plus IB form. If it is real number, then imaginary part is 0. Abdul Mateen, yes, even if you I know, if you are Abdul Mateen, you have written, you have some net issue, you are going out, no problem. Even if you are going out, I am letting you in. Only thing is, if your name is in that format, I am letting everyone in. Those who are not writing roll number, class, and everything, I am not letting them in. Next one. I raised to 9. Z is equal to I raised to 9 plus I raised to 90. Again, yesterday we learned I raised to 9. For odd multiple, we learned I raised to 8 into I. This also I raised to 18 into I. Higher powers of I, if it is odd number, if it is writing I is necessary. Writing I is one of you asked, writing I is necessary. Because the question is to write that in A plus IB form. If the question is to write in A plus IB form, then A should be in A plus IB form. To evaluate higher powers of I, write in even power can be written as I square raised to something. So I raised to 8 can be written as I square raised to 4 into I. I raised to 18 can be written as I raised to 9 the whole square into I. So we could write in terms of I square. Why did we write so? Because the value of I square, it is -1. -1 raised to 4I plus -1 raised to 9I. Again, -1 raised to even power is +1. So this is I. -1 raised to odd power is -1. -I. -1 raised to an even number will become +1. +1. -1 raised to an odd number will become -1. So -1 raised to 4 is +1. +1 into I. -1 raised to odd number is -1. -1 into I is -1. I minus I is 0. Therefore, our aim is to write that in A plus IB form. So how much will A plus 0I? A plus IB form. Third one. 1 plus 1. Power in step 2. If sir, it is 1 plus 1, not 1 plus 1, 1 minus 1 raised to 9 is minus 1. Minus 1 into I is minus I. Minus 1 into I is minus I. Then another doubt is not. So what are the powers in step 2? Powers in step 2. This one. I raised to 9, we got it as I raised to 8 and I, so that 8 plus 1 is 9. I raised to 19 can be as I raised to 18 into I. In third line you wrote I raised to 9 the whole square. Yes, yes, yes. This is correct. This is correct. This is I square the whole is 9. Not I raised to 9 the whole square. I square, that's right. That is correct. I square, always write in powers of I square. Next one. Third one, I raised to minus 13. So Z is equal to I raised to minus 39. Z is, if the exponent is positive, we are comfortable. How to make it as positive? 1 by I raised to 39. 1 by I raised to 39, again writing even power, make it as even power. I raised to 38 into I. This even power can be written in terms of I squared, 19 into I. Always even power. First make it as even powers. Here also we made it as even powers. Then the even power, make it as powers of I squared. That is why we are writing it as even power. Once if you are written even power, we can write it as powers of I squared. So this is 1 by I square value is minus 1 raised to 90 into I. Minus 1 raised to what number is minus 1 only. So it is 1 by minus I. Z is equal to 1 by minus I. See again, like in rationalization, we never remember it, we never keep I in denominator. In any expression, we never keep I in denominator. So whenever I comes in denominator, what to do? Whenever I comes in denominator, multiply it with one more I, like rationalization. If you are multiplying denominator with I, numerator also multiplied with I. So whenever I comes in denominator, multiply both numerator and denominator with one more I, so that I, what did I say? Denominator I into I becomes I square. This minus sign is there, minus I square. It became minus I square. I by minus I square is minus 1. Minus of minus 1 is 1. So we got Z is equal to 1. That is 0 plus I. The question should write in here plus I. Next one. Question number 4. So remember, to evaluate powers of I, write it as even power. Even if it is odd power, write it as even power into I. Then that even power can be written as I square with a power. So that the value of I square minus 1 we can replace. Fourth one is 3 into 7 plus I 7. 7 plus I into 7. plus I into 7 plus I square. It's nothing, directly opening, like in algebraic expressions. Directly open the bracket. Whatever you get, then simplify. So directly opening 3 into 7, 21 plus 3 into 7 I. So 21 I plus I into 7 is 7 I plus I into 7 I is I square into 7. 21. This 21 I plus 7 I, like normal addition, it is 28 I. I square is minus, so minus 7. Reason I square is minus 1. If you replace I square with minus 1 into 7, it is minus 7. I square, the value of I square is minus 1. So minus 1 into 7 is minus 7. Now, real part first. 21 minus 7 is 14 plus I into 20. That's it. Or 28. 28I or I into 28 doesn't make a difference. Whether you write 28I or I into 28 doesn't make a difference. Both way option. Next one. Fifth one is a homework. Fifth and sixth one. Question number. Whether you write Z is equal to or not or not. Okay, Z. Someone not be follow right Z. Okay. Fifth and sixth are homework. Now question number 7. We will do question number 7. Question number 7. Whether you write, someone wrote Z, you forgot write Z. Whether you write Z or not, no problem. It's a complex number. Okay, I'm writing Z. Z is equal to 1 by 3 plus I into 7 by 3 plus 4 plus I into 1 by 3. It's square bracket minus of minus 4 by 3 plus I. Like normal simplification. Simplify. First one we can open the bracket. First one. So square bracket this 1 by 3 I into 7 by 3 plus 4 plus I into 1 by 3. I already minus of minus is plus 4 by 3 minus I. Again, here writing the real part first. 1 by 3 plus 4 plus I into 7 by 3 plus 1 by 3 is it? 1 by 3 and 4. I added real part like in algebraic expressions. These two numbers can be added again like this. Plus 4 by 3 minus 1 by 3 plus 4 is, or again like all real parts together. Which are the real parts? This one, this one, this one. So I am writing it together. 1 by 3 plus 4 plus 4 by 3 in a bracket. I wrote all real parts together. Now plus I into imaginary parts. 7 by 3, 1 by 3 minus 1. Common factor. Now simplify. Here LCM 3. 1 plus 12 plus 4 plus I into again LCM 3. 7 plus 1 minus 3. This is 17 by 3 plus I into 7 plus 1, 8 minus 3, 5 by 3. That's it. 17 by 3. Normal simplification. Normal simplification. Where did you get minus 1? Minus 1. I think the previous question you were asking, one of you asked me from Zaid Qadri. Where did you get minus 1? My I square is minus 1. The value of I square is minus 1. Zaid Qadri. You asked me from where did you get minus 1? I square, I replace I, the previous question. Check that answer. I square is minus 1. The value of I square is minus 1. Let me take the attendance. Without writing. Now coming to question number 8. 1 minus I the whole raised to 1 minus I the whole raised to 4. Z is equal to 1 minus I the whole raised to 4. See, remember this you learn later on also you learn A minus B the whole raised to 4. The identity A minus B this year till last year you learned A plus B the whole square, A plus B the whole cube. Now you will learn A plus B the whole raised to 4, A plus B the whole raised to 5, A plus B whole raised to 6, etc. up to n, A plus B the whole raised to n. That is called the binomial expansion. We will learn later on. But A plus B or A minus B the whole raised to 4, you have to remember it is A raised to 4 minus 4A cube B plus 6A square B square minus 4 A B cube plus B raised to 4. A raised to 4 minus 4A cube B plus 6A square B square minus 4AB cube plus B raised to 4. Remember this expansion. This expansion is a technique that we'll discuss later on. We can remember all these expansions very easily. So using that 1 raised to 4 instead of A 1 instead of B I minus 4 1 cube into I plus 6 1 square into I square minus 4 1 into I cube plus I raised to 4. I raised to 4. A minus B the whole raised to 4. Here instead of A and B, we replace it with. Yes, one of you asked me, can we, yes, what's your problem, Abdullah? One of you asked me, can we use A minus B the whole square? Yes, no problem. First A minus B the whole square, then you will get 3 terms, then A plus B plus C the whole square, no problem. But this is better. 1 raised to 4 is 1 minus 4, 1 cube is 1, I is I, 6, 1 square is 1, I square is minus 1, minus 4, 1, I cube inside, right? I cube is I square into I, minus 1 into I, which is minus I. Remember it? I cube is minus I. Yesterday we wrote that. I cube is minus I. Again, I raised to 4. I raised to 4 is I square the whole square minus 1 the whole square, I get 1. So remember the first 4 values, remember it. I square minus 1, I cube minus I raised to 4, 1. Actually, that cycle goes on. I minus 1, minus I, 1. Again, I minus 1, minus I, 1. That is 5, I raised to 5, I raised to 6, I raised to 7, I raised to 8. These 4 values keeps on repeating. I think you got the idea. These 4 values. Which are the values? I, then minus 1, I square, minus I, 1. These 4 values keeps on repeating. That means I, this is I square, I cube, I raised to 4. Again, I raised to 5 is I only. I raised to 6, I raised to 7, I raised to 8. These 4 values goes in a cycle. So minus 4 into 1 into I cube we wrote it as minus I plus I raised to 4 is 1. This is 1 minus 4I minus 6 minus into minus is plus 4I plus 1. Now write all real parts together. Writing real parts together. 1 minus 6 plus 1 minus 48 plus 48 cancel. So it is minus 4. Therefore, Z can be written as minus 4 plus 0.5 in A plus IB form. Now, similarly, question number 9 and 10, try this homework. 9 and 10, A plus B the whole cube, you know the expansion. Now, question number 11. Question number 11. Question number 11. The question is to write the multiplicative inverse. So, Z is equal to 4 minus 3i. This question can be asked. Writing multiplicative inverse and conjugate or modulus can be asked in your test also. See that to find the multiplicative inverse, z raised to minus 1. We have the formula z bar by modulus x square. So if z is given, first we will find z bar. Z bar stands for the conjugate. Conjugate means the complex number which differ in the sign of the imaginary part. So for minus 3i, if we change sign of the imaginary part, 4 plus 3i. This is the conjugate z bar. Now we have to find. Modulus. So modulus of z is, again remember it, if z is equal to a plus ib, z bar is a minus ib, modulus of z is root of a square plus b square. This we know. So modulus is root of a square plus b square becomes 4 square plus minus 3 square, root of 16 plus 9, root 25. Then modulus x square will be 25 because root 25 root goes. Now z inverse is z bar by modulus x square That is 4 plus 3i by 25. 4 by 25 plus I into 3 by 25. Here plus IB form. Real part separate, imaginary part separate. Such questions can be asked for examination also. Now question number 12. Root 5 plus 3. I hope we have completed this. Question number 12. Root 5 plus 3i. Exactly same. Do it. The root 5 plus 3i. Try by yourself. Do it. First z bar. To write z bar, change the sign of the imaginary part. So it is root 5 minus 3i. That is z bar. Now, modulus of z. Modulus of z, the formula is root of a square plus. Can we, another doubt? Can we add 7 by 3 plus I? Okay, can we add this? Yes. One of you see, simple thing. 5 plus 3. 5 plus 3 we can add. It is 8. 5 plus 3i, the question is can be added. If you are adding, use normal algebraic expressions. Can we add 5 plus 3x? 5 plus 3x. Is it 8x? No. 5 plus 3x only like terms can be added. 5x plus 3x can be added. 5 plus 3x remains as it is. That is why 5 plus 3i, if you are adding what we write, we cannot write as 8i. Yes. No, you asked this doubt before only. I saw that doubt, now only that's I'm saying. So we cannot write it. No problem. What do you have doubt? Genuine doubts, no problem. Yes. Now, yes, completed. I think you may have completed. Modulus of the is root of root 5 square plus 3 square. Root of 5 square is 5 plus 9, which is root 14. So modulus will be 14. It is 14. Then z bar root 5 minus 3i by 14, which is the root 5 by 14 minus I into 3 by 14. Next one. Question number 13. Minus I. Question number 13. Again minus I. Do it. Minus I means 0 minus I. So z bar will be 0 plus I. Is it? Minus I means 0 minus I. When writing in channel form. So modulus of it is 0 square plus 1 square, which is 1. That's also 1. So z bar is 0 plus I by 1, which is 0 plus I. So inverse of minus I is I only. Now the last question. Question number 14. Don't get scared by seeing lot of expressions. It's very easy. 3 plus 3 plus I root 5 into 3 minus I root 5. 3 minus I root 5 divided by root 3 plus root 2I, root 3 plus root 2I minus of root 3 minus I root 2 minus I root 2 and root 3 both are same only. Numerator you can see it is of the form a plus b into a minus b, which is a square minus I root 5 square. A square minus b square. Denominator opening bracket root 3 plus root 2I minus root 3 plus I root 2. Now numerator. Numerator is 3 square 9 minus I square into 5. Root 5 square is 5. Square of I is I square. By this root 3 minus root 3 cancels. Root 2I, this is also I root 2 is again root 2I. Root 2I plus root 2I will be, see if you have doubt, what is root 2x plus root 2x? Whenever you come across any doubt, instead of I, we are familiar with x and y, algebraic expression. What is yes? The root 2x plus root 2x, will it be root 4x? No. Root 2x plus, so can we write minus before also? What is it? One of your doubt. Can we write minus by square also for number? I didn't get your doubt, Abdullah Basit. Can we write? Wait. Can we write minus before square also for numbers? Minus before square for. I think you are. Yeah, a plus b into a minus b, a square minus b square. We can write minus before square of number. See, 5 square minus 5 square, no problem. And these are different numbers. 5 square means 25. Minus 5 the whole square is again 25. Minus 5 square means minus 25. We can write minus before square of number. No problem. Square of number will not be negative, but negative of square is positive. Yeah. So root 2x plus root 2x is not root 4x. Root 2x plus root 2x is 2 times root 2x, 2 root x. So here, similarly, root 2i plus root 2i is 2 root 2i. 2 root 2i. This is 9 minus I square. Minus I square is minus 1 into 5. Minus 1 into 5 by 2 root 2i. 2 root 2i. This is 9 plus minus plus 9 plus 5 by 2 root 2i. See, generally, we will not keep irrational. This is 9 plus 5, 14 by 2 root 2i. 2 this cancels. 7 by root 2i. Again, we discuss it. We never keep I in denominator. We never keep I in denominator. So multiplying, similarly root also, right? So multiplying this with root 2i, root 2i. Numerator is 7 root 2i. Root 2 into root 2 is 2. I into I is I squared. This is 7 root 2i by minus 2. By minus 2, I squared is minus 1. Therefore, this is the imaginary part with I. So we can write the 0 minus 7 root 2i by 2. That's it. Real part and imaginary part. 0 minus 7 root 2i by 2. Remember, like rationalizing denominator, we will not keep irrational number in denominator generally. If you are getting root 2 in denominator, multiply by root 2. Similarly, if you are getting I in denominator also, multiply with I so that I into I becomes I square, which is minus 1. Now, the doubts you ask one by one. Class is over, it said. I was asking the identity as no, I was asking the identity 2 a square minus b square for numerator. Okay. We could cancel I. In step 3, we could cancel I. In step 3, we could cancel I. Okay, this I cannot be cancelled. Now, numerator we have 2 terms. We cannot cancel it. We cannot cancel the sign because the sign numerator we have 2 terms. See, for example, if you get some 9 minus 2 into 5 by 2 into 3, we cannot cancel this 2 and 2. Why? Because numerator we have 2 terms. Similarly, we cannot cancel this I. I didn't understand that which portion you said. I didn't understand that part. That part means which part? One of you wrote. I didn't understand that part. Which part you didn't mention? What if we divide 7 by 2 and get array? Why to divide? Keep it as fractions. Don't divide it, keep it as fractions only. Don't go for dividing it. Abdul Majid wrote, what if it, no. Afan wrote, I didn't understand part. Afan, from step 3 you didn't understand. 1, 2, 3. From this step 3, here I square and root 5 square is 5. Then the value of 5, see 9, I wrote as it is. This minus sign, I wrote as it is. I square, the value of I square is minus 1. You remember it? I think previously also you asked, how did we get minus 1? I square is minus 1. This 5 as it is. Denominator, I wrote as it is. So minus of minus is plus. 9 plus 5 is 14. Then 1400 cancel. And whenever we get denominator irrational and imaginary part, we multiply it. That's it. So the portion for your unit test is over. And in trigonometry, from miscellaneous exercise, the chances of asking question is less this time. Trigonometry, in miscellaneous questions, the chances are less. Remaining proving questions, they can ask. Giving LHS on simplification, right hand side, MCQ. We can give 4 options. Which one is correct? So left hand side, simplify and without giving right hand side. One of you asked me, are you making paper? Why do you bother about who makes the paper? One of the math teachers will make the paper. We'll have class on Saturday. Then we will, if your exam starts on Saturday, the circular will come to you. I think during examination, they are planning for NID, non-instructional days. They're planning. Anyway, it will be intimated to you. So, trigonometry, even proving questions. What about chapter 4? Sir, please take extra classes. Why to take extra classes? Because even I have seen biology students for extra classes during this vacation also. Extra classes, we were during Ramadan vacation, we were ready to put extra classes, but majority of you people only wrote against it. What is the meaning of the vacation? holidays are holidays. Why do you give extra classes? So no extra classes. Javed sir told no classes during unit exams. Yes, if Javed sir said it, that's it, because he's HM in charge. So our portion for unit test is over. So extra classes we won't be able to attend because we have to learn for the particular exam. Yes, yeah, I'm not giving extra classes. I'm not giving extra classes. Then anything else? Again, as I said, revision class, revision class 1. Revision, no need of, because revision usually someone wrote it. No need of extra class. So no need of extra class. If you're in doubt, one of you wrote nice haircut. I'm becoming self-sufficient. We have to cross or the, do we have to be in Zoom call? Yeah, camera. That is what the discussion goes on. During examination, you should be in Zoom class with camera on to check whether you are copying or not. But in maths examination, you will not get time to copy because the question will be lengthy. 20 questions in 1.5 hours. You will, if you are looking here and there, you will not get time to complete it. So those who want to come in extra classes, you can give for no. So this is a lesson coming for you. Yes, this is coming for unit test. The first exercise, complex numbers. First exercise is coming for unit test. Anything else? But sir, on internet will come slow if you Zoom is on. No, internet even Zoom it is slow. No problem for answering questions. Only you have to check it. So in test portal, it won't take much. One more thing is chapter 4. Chapter 4 is not there. Not chapter 4. Only chapter 3. Then this is chapter 5. Chapter 4 we didn't teach. Whatever we taught, examination, whatever we taught is coming. Then only in trigonometry, miscellaneous. No, most probably it won't. No, not most probably. It will not be asked. Remaining exercise, go through it. Okay. So all the best. We will see it next class. So if you open a different browser during the exam, now those points can be discussed with your class teacher. If you open a different browser during exam, camera closes by its own. That issues we will discuss it because Zoom. So how can we use touch portal and Zoom at the same? I think we can use. That is what I heard because few people used it. You can use touch portal and Zoom at the same time. Is there class on Saturday? Saturday there is no class, I think. Okay, Afan, you wrote no. Then if it is no, anyway, discussion is going on with this exam department. But exam department, for the time being, the information and intimation given to us is you can open. That is what they say. Anyway, we'll see to it once again, right? Zoom will end after, but Zoom will end after 40 minutes only for. See now also. When I am taking classes, it is not ending by 40 minutes, and you are also not. Depends on the host. If I have a version for more than 40, see, for me, I have this one. It is not stopping by 40 minutes. You might have observed it. More than 1 hour. If Zoom meeting ends in the middle of exam, you notify the teacher that the time has changed. No. So see, we have. I can invigilate more than 1 hour, 1.5 hours. You have premium version, yes. Not because of rich. Premium version, I arrange it because I don't want to see you in logging out again, coming in. Okay, anything else? So you take, if you have any doubt, you can ask me, no problem. You take, yes, Nandakishore also, if you have any doubt in between, if you come across any doubt, you call me directly or text me, no problem. At any time, 24/7, 24 hours service. At any time, if you come across any doubt, text me. If I'm not sleeping, I will answer it. Okay. So nothing else. All the best.